All right, let's talk about something you've probably seen 1,000 times in a garage, the hydraulic jack. It's this, incredibly simple looking tool, but it gives you what feels like superhuman strength. So how does it do that? We're going to break it down.
No, I mean, really think about it. How can your arm, with just a little bit of effort, lift a 3,000-pound car? That's nuts. It feels like it shouldn't be possible, right? It's like something out of a comic book. Well, it's not magic, and it's definitely not a superpower. It's physics. The secret isn't about how strong you are. It's all about how cleverly we can use a basic law of physics to turn a little bit of your effort into this massive, incredible force. And that secret, that core principle, is something called Pascal's law. This one idea, figured out hundreds of years ago, is basically the engine that drives every hydraulic system out there. It's that important. Okay, so the definition sounds a little textbooky, right? But the idea itself is actually super simple. Imagine you've got some liquid trapped in a container, like the oil in a jack. If you squeeze it, the pressure doesn't just shoot out in one spot. Nope. It spreads out perfectly evenly in all directions, all at once. That right there, that's the key to everything. So how do we actually use that? Let's picture it. You've got two pistons connected by a tube full of fluid. One piston is small, the other one's big. Now, what happens if we push down on that little piston? We create pressure in the fluid, right? And because of Pascal's law, that exact same pressure is now pushing up on the big piston. So, what's the result? And this is where the magic happens. You remember that little formula, force equals pressure times area? Well, if the pressure is the same on both sides, but the big piston has, say, 10 times the area, it's going to produce 10 times the force. You push with 100 pounds of force on the small side, and boom, you get 1,000 pounds of lifting force on the big side. That's it right there, a 10x multiplier. A 10-to-1 mechanical advantage. You've just made yourself 10 times stronger, just by using some fluid and a little bit of smart design. It's genius, really.
Okay, so that's the theory, the basic physics behind it all. But how does an actual jack use this idea? With the handle you pump up and down? Let's peek inside and see how the whole cycle works. So when you lift the handle up, that's called the upstroke. What you're doing is pulling a little piston back. This creates a vacuum, kind of like a syringe, and it sucks oil in from a storage tank, the reservoir, through a little one-way door or check valve. You're basically loading up the chamber for the push. Okay, now for the downstroke. You push the handle down, that little one-way door you just used slams shut so the oil can't go back. Instead, you force it through another one-way door, this time into the main cylinder, right underneath the big piston that does the lifting. And with every single pump, you're just squirting a little more oil in there, pushing that big ram up inch by tiny inch. But here's the thing. The force multiplication is actually way, way more impressive than that simple 10-to-1 example we just used. And of course, when you're dealing with that much power, safety becomes absolutely critical. All right, let's start with you. Let's say you're putting about 50 pounds of force onto the handle. A pretty normal amount of effort. That's our starting point. But wait, before we even get to the hydraulics, there's another bit of simple physics at play. The handle is a lever. Just that simple lever action can multiply your force, maybe 5 times over. So your 50-pound push is already 250 pounds of force before the oil even does anything. See? We're already amplifying it. Now we bring in Pascal's law. Let's use that same 10-to-1 piston ratio we talked about. You take that 250 pounds and multiply it by 10. What do you get? 2,500 pounds of lifting force. That's over a ton from just a 50-pound push of your arm. That is just unbelievable when you think about it. You may be wondering, why do we have to use that special hydraulic oil? Why not just water or even air? Well, air is a big no-no because you can squash it. It's compressible. You'd just be squeezing a sponge. Oil, on the other hand, is basically incompressible. It transfers that pressure almost perfectly. Plus, it lubricates all the moving parts and keeps everything from rusting. It's just the perfect stuff for this.
Okay, now this is really, really important. A jack is a lifting device. It is not a support device. That hydraulic pressure is what's holding everything up, and you know what? Seals can leak, they can fail. So please never, ever get under a car that's only held up by a jack. You always, always have to use jack stands. It's not a suggestion, it could literally save your life.
And you'll notice every jack has a load rating, like 2 ton or 3 ton. And there's a very good reason for that. Everything from the thickness of the steel to how strong the seals are, to the design of the whole frame, it's all engineered to handle a specific amount of weight. If you try to lift more than that, you're risking a total catastrophic failure. So when you look at a hydraulic jack, you're not just looking at a tool for changing a tire. You're looking at the result of long history of humans trying to figure out how to multiply force. And the principle inside that little jack, well, it powers some of the biggest, most powerful machines in the world. It all started way back in the 1600s when Blaise Pascal first figured out the whole fluid pressure thing. Then, in the 1800s, a guy named Joseph Bramah used that idea to build the first big hydraulic presses. But it wasn't until the 20th century, with better materials and machining, that we could make them small, reliable, and cheap enough for everybody to have one in their garage. And once you know what to look for, you see this principle everywhere. You see a huge excavator digging a hole? That's all hydraulics. An airplane lowering its landing gear? Hydraulics. The brakes that stop your car? Yep, that's hydraulics too. The little jack is just our most familiar window into this massive, world-changing technology. But as always in physics, there's no such thing as a free lunch. There's a trade-off. To get that 10x force multiplication, you have to move your end of the deal, the handle, 10 times the distance. So you do lots of long, easy pumps to get one short, powerful lift on the other end. You're trading distance for force. Energy is always conserved. So from now on, when you see a hydraulic jack, you're not just going to see a tool, right? You're going to see Pascal's law, right there in action, turning a simple motion into incredible power. And it really makes you think, what other pieces of everyday magic are all around us, just waiting for us to see the simple physics hiding in plain sight?